Hello. Oh, hello, hello, hello. That's better. How are you all doing today? Excellent, excellent. Last session of the day, right? Kind of the one where everybody's kind of sleepy, but I'll try to keep you entertained. I'll try to stay energized for you. My name is Spencer Schneidenbach, and I'm here to talk to you today about why you should use types in your JavaScript. I gave this presentation a few weeks ago in my hometown of St. Louis, Missouri, and I started out with a slide. I started out with a slide that looked like this, and I said, America, we need to talk. But the only problem is I'm not in America. I am in Poland, which is a beautiful country. This is my first time in Poland. I'm thrilled to be here, and everybody's been so welcoming and accommodating, so I really appreciate that. But without further ado, Poland, we need to talk. We need to talk about the web specifically. I picked this image off of Google Images a few weeks ago because I thought, well, it kind of illustrated one of the points I was trying to make, in that there's a lot that goes into the web, right? How many of you are .NET developers? Okay, a good amount of you. So you know what this looks like, right? You know, you've heard of this thing, right? How many people ASP.NET developers specifically? All right. I mean, there's a lot that goes into ASP.NET, right? I mean, you have to know C#, and if you're working on a front end, of course you have to know JavaScript and HTML and CSS. There's just a lot to learn. There's a lot to know, right? And this is a curiosity. First, was anybody at the user group last night that saw my session, just out of curiosity? Okay, so I already told this joke, all right? I already said this, so this will sound familiar, but how many people do this? This is the only web forms logo that I could find. Okay. Couple of people, let's see some hands. Come on, raise them up, right? I love asking this question because inevitably people are shy to answer. At a conference that I was at in Kansas City a couple months ago, I literally had a guy, I asked this question, literally a guy kind of, he doesn't want to answer the question. There's a lot that goes into web forms. I'm still a web forms developer. I have clients that use it. And that's okay, right? But we're not here to talk about that. We're here to talk about this, right? We're here to talk about the fun that is trying to style your web page. No, I'm kidding. I'm kidding. But if anybody's ever used CSS and tried to do something serious, you might have ended up with this result. No, I'm here to talk about the one inalienable truth of the web. How many people are JavaScript developers or use JavaScript at all? Okay, good amount of you, good amount of you. So then you can all agree with this one universal truth, which is that JavaScript is weird. JavaScript is really a strange language, right? It was invented, 20 years ago by a guy named Brendan Eich. He made it in 10 days. That gives you an idea, and he set us up for the rest of the web for 20, 25 years later. And as Todd Gardner of Track.js says, there's just more and more JavaScript, bad JavaScript being written every day. And JavaScript doesn't help, right? Let's look at a few examples of weirdness. So we have this, maybe a little bit of code that might kind of seem a little bit familiar, right? You're getting a customer, a reference to a customer, and you want to get their orders, right? Maybe it's a promise, maybe it's whatever the interface is, right? You want to get some orders and display them on a web page, right? But the thing about JavaScript is that it really doesn't try to get in your way enough, right? If you do something like this, right? Check it, very subtle, right? You check that S. There's now an S there, right? You check get orders or dairies, right? This is something that's totally valid, and JavaScript's like, yeah, great, I love it. You know, you probably knew what you were talking about. I don't know what I'm talking about, so you probably know that this method exists on this object, right? You're good to go. And then if it's like 11:30 on a Friday, right, you might see something like this. You might be hungry, and you'd say, well, I want to get some hors d'oeuvres for lunch, right? This is totally possible, and JavaScript is absolutely, it's there to help you, right? It's there to tell you, yeah, it's encouraging. Yeah, we're great, we're good. This looks like perfect code, right? Because it's an object, and forget it might be undefined, it might not be, but it looks cool, right? One of the best phrases I think I've heard is, JavaScript tries to help you, don't let it, right? And this is one of those ideas about JavaScript helping you when it probably shouldn't. Let's talk about this. This is such a confusing thing 20 years later that when I first did a presentation similar to this, I Googled for articles on this, okay? And I found these articles, just random links, right? And they were all written within 2 weeks of when I Googled it. We're still talking about this because this is still confusing. And just to give you an example, if you're familiar or not with JavaScript, this may tease your mind. It did for me for a while, right? So we access the window object in a browser that exists in a browser. We say, I'm the window object. And then we create a function that sets itself to this.whoami, same property, right? And it says, I'm the test object. So we run this, and we run this function. We run this test function. And what's the inevitable result? The inevitable result is that what we're going to end up with window.whoami is going to say I'm the test object, and t is going to be undefined, and you're going to get a runtime error, right? And JavaScript's like, great. You know, you called this function. Obviously, you know what you're doing because you wanted that function to implicitly capture the window object as this. That's exactly what you intended, right? Whereas you probably intended to do something like this, where you wanted to use new test, right? Which creates a new instance. It becomes a constructor function, and now it's an object of its own. And now your code behaves as you expect. But again, JavaScript is just there. It's just there to help you. It's just there to encourage you. It's just there to move you along because it figures that you know what you're doing. And guess what? I don't always know what I'm doing. And if I don't, then, well, you probably do, but not in the case of JavaScript. Let's talk about some of its idiosyncrasies just a little bit. This is making fun of JavaScript, which is super easy. If you follow a guy named David Neal on Twitter, you'll see he makes fun of JavaScript every day. He does it a lot funnier than I do, too. But let's talk about undefined and null, right? It's strange enough that there's two kinds of ways to represent the absence of something, right? Then you get something like when you're trying to check the type of undefined, you get undefined. Okay, so it means something on its own. It's something on its own. And then you check the type of null, and you return object, right? And this is just, I don't know, it's just weird. It's strange. It's not predictable. That's the bottom line with JavaScript. It's just not predictable. And then, of course, we love this, right? If you call get hors d'oeuvres, this is what you're going to get. It's going to be undefined, and undefined is not a function. Is basically a huge part of my day, or at least it used to be. Getting back to that idea that JavaScript is just weird. It's just a strange language. And if that didn't convince you, then I don't know what will. But let's continue on that thesis, okay? How can we make the weird less weird? How can we make it different? How can we make it better? Most important things you can do. Understand JavaScript completely, okay? Read the ECMAScript spec, understand what hoisting is, understand how it manages memory, right? Or understand its little weirdness that, like I said, you can't just predict because it's not predictable. It's not predictable, especially for people who come from other languages. It just behaves away on its own. So you can understand JavaScript completely. That's thing one, right? You can also be perfect 100% of the time. I don't know that that's possible. I don't think I can be these things, right? And then, of course, you can write tests. You can write tests in Jest or Jasmine or whatever. You can write tests for your JavaScript because we all write unit tests, right? Right. So these things are things that you can do to make JavaScript less weird. But the bottom line is that these are really hard things to do, right? Learning how to test JavaScript, probably the easiest of them. Understanding JavaScript completely. You don't live in a silo. You don't work alone. Maybe you're a corporate developer. I used to be one where I was just one guy and the programmer at a desk. So I could kind of figure it out on my own. But then as that team grows, right, you go from 1 to 2. You've got people that are C#, and suddenly they have to work on the web. And then they have to learn JavaScript. And it's like starting from scratch, right? You have to teach them all the weirdness, right? You have to pass that knowledge on. So this is a really hard thing to do because we don't work alone, and everybody has varying levels of skill, right? I certainly don't claim to be a JavaScript expert, right? I just know that it's weird, and that seems to have gotten me along just fine. The number 2 thing that you can do to get rid of JavaScript's weirdness is use a type system. So I'm finally getting to the thesis of the talk, right? As my big thing, the thing that seemed to improve me the most, was introducing the idea of types in my code. Type systems add certainty, right? They add guarantees. That's the big sell for them, right? And JavaScript doesn't have them. It has the concept of types, of course. They have type number, object, function, all of those, they do, but they don't lack a very good type system that helps you at runtime, right? And this is where type systems can come in and help you. Type systems can add certainty to your code where JavaScript lacked it, okay? It's all about certainty. And if you're a .NET developer, which I saw enough hands raised, we all can understand that certainty is good. unless, of course, you do something like turn off options strict on VB.net. How many VB.net people in here? Okay, a few. I still use VB.net. How many people were too embarrassed to raise their hand when I asked that question? All right. So I see three main advantages to type systems, right? I see the type safety as being one advantage. I see tooling as being a huge advantage. And then I see self-documenting code. And we're going to go through examples of all of these. But first, you shouldn't take my word for it. Let me talk to you about some companies who have recently, very recently, introduced types to their JavaScript and made their lives easier. Start with Reddit. How many people are Reddit users? So Reddit has a pretty decent engineering blog behind it. And Reddit is one of the top 10 most visited websites on the internet. And Reddit is a very, very high volume website and has a big engineering team. And their blog, they update it pretty recently, and they update it pretty frequently. And one of the most recent articles that came out of it was the introduction to types, right? So they went through the whole process. They didn't just say, we implemented this and this was the result. They said, we were searching for something to make JavaScript lives easier, our JavaScript lives easier. And they said, well, inevitably we figured that we wanted a language with a type system. And they looked at more than 10 languages to figure out what kind of type system they wanted, or what kind of typed JavaScript they wanted to support, right? And so they wrote all their reasons. They wrote exactly what they were looking for. We're looking for certainty. We're looking for speed of development. We're looking to reduce the number of bugs, right? These are all great reasons to search for type systems. And what they found is they came to several conclusions. They inevitably implemented TypeScript. They looked at things like Flow and even other languages like ReasonML. But they found that TypeScript really worked for them and really worked for their process. And they said the first thing that they found is that types serve as documentation at the micro level. And we'll go through an example of that in a little bit. They serve as documentation at the micro level. They help ensure correctness. They help ensure correctness of code, right? Because there's a type system, the compiler is able to interpret and say, at runtime, I can make these guarantees. I can guarantee that given this interface that you've declared, you should have these properties and these methods. And if you declare something that is of this interface, I expect to see all of those, right? Helps ensure correctness, and they help make refactoring code less stressful. And I cannot tell you how crazy and good this concept is, right? The idea that the thing about JavaScript is that it's really hard for good tooling to come in and refactor. How many people love ReSharper? ReSharper is one of my favorite tools. Good, I'm glad to see a lot of hands. If you don't use ReSharper, download it, you should, if you're a .NET developer, which most of you are. But even the magic of ReSharper, one of the key advantages to me for ReSharper is the amount of refactoring tooling that they give you to extract methods out of other methods so you can break your code down, to rename variables really easily and rename them globally across projects, right? How many people have ever tried to refactor JavaScript by using ReSharper's system and then they broke something? Or they did a find and replace and and you hoped that it would work, right? I see a few hands, right? I'm guilty of that. I've done it before. I've broken my code. I've broken my workflow by trying to make ReSharper work with JavaScript. And ReSharper does a pretty good job, but it can't be perfect. And part of that is just the lack of a type system. You can't, at compile time or at writing time, it cannot predict very well when a variable uses this property with this name, that very variable is the same one that's used in a completely separate part, right? If you've got two first name variables, which one are you wanting to refactor? It's very difficult to figure that out. It's very difficult. But a type system can add to that. By adding that certainty, not only for your code, it adds some guarantees about its own code that says, I know that I can refactor this safely because I know that this interface is used here, here, and here, which is awesome, which is an awesome feeling. Let's talk about an example. So this is something, most of these code examples, actually all of them are in TypeScript. I'm a TypeScript user personally, but a lot of these with some subtle syntax changes can be used in Flow as well. So let's talk about the person interface. So what we have here is just basically a contract, right? This is a guarantee that any object that uses this interface will have a first name and a last name, and may or may not have an age, right? So the question mark meaning that it's an optional property, right? And you can leave it off of your object, and then you just are forced to check for truthiness or falsiness, which of course is another JavaScript weirdness that is another show. So when you declare a person, right, when you declare a variable and you say this is a type, this object is of type person, right? And you can say that by adding a nice little type annotation right there in the middle. Right after the variable declaration, you give it a little type annotation. You say this is the person object, right? And then you can say, here's the shape of that. Here's an object that implements this interface. You can give it a first name and last name, and then you can redeclare it with an age, right? So these are all good things. And the reason this is good things is because we're not perfect. If you misspell first name to first name or whatever, it's going to tell you. TypeScript and Flow are going to give you that feedback immediately. And they're going to display errors that show you, well, this is where you screwed up, and you need to go and fix it. And the same thing, if you can add, just like an interface in C# or VB.NET, you can add, or Java, you can add methods to these as well. So you can add a method to this, and then when you declare it, you better be sure that that method that you're declaring better have the exact signature that it says that it should have, and as well as the return type that it should have. So these are all great things, because that means we get some really great guarantees about our code when we write it. Another consideration was the speed of development. They said that this is antithetical, I think I'm saying that right, to the idea of types, where most people intuitively believe that types actually slow down the development process, because now you're having to declare those person interfaces, those employee interfaces. You're having to model your objects again in another language, which is, in this case, TypeScript, Flow, whatever. But they said that they wanted to move quickly. And types were the best way to do that, because the thing about moving quickly is that the quicker you move, the quicker it is to introduce bugs. It's true. And types really add to that, really take away that. They're kind of like unit tests. They're a little bit more investment of time up front, but in a long term, they'll pay off, right? Because they're giving those guarantees. They're giving you that safety that you desire. I'm going to link to these slides in my Twitter account. I would highly suggest you click on this and read this article if you're strongly considering using types in your JavaScript. Just a quick show of hands. How many people do use TypeScript or Flow or something like that? Okay, a good amount of you. Great, I love it. This is out of curiosity. For this is for everybody else, right? No, there's plenty of advantages. There might be something you missed. So let's check it out, right? So they said, what is the result of what we've done? They said our code has fewer type-related bugs. So that means that they are fewer undefined, fewer property misses, fewer method misses, right? Because they have that structural typing ahead of time that says these things are guaranteed to be there. So our code has fewer type-related bugs, and they're more confident making large refactors, which is maybe, to me, one of the best features of a type system is, again, the ability to refactor and the ability to refactor safely. Because when you refactor that first name, you can use your tooling to say, I just want to rename this variable. And your tooling knows exactly what to do, because you've declared that interface over several places. So they said they're more confident making large refactors. How many people use plain JavaScript and are very confident when they extract a method or they rename a property? No hands should go up. My hand certainly wouldn't. Also, they found that their inline documentation was more focused on concepts and less about object shapes and function parameters. Now, let me describe this to you. How many people use jQuery? How many people have used Okay, lots of people use jQuery. I still love jQuery. jQuery is like duct tape. Duct tape will fix anything, so will jQuery on the web. jQuery is the duct tape of the web. And one of the things about jQuery and most other libraries is that they have the ability to take arguments with different shapes. So you could have an AJAX call, right? $.ajax, where you can pass in a string or you can pass in an option set. Now, in JavaScript, there's no constraints about picking either of those things. You could pass in a number and it's not going to complain. But the thing about documenting that is now you have to go through, if you've ever looked at the jQuery docs, you have to actually then go through and figure out, well, what is the shape of the object that this argument needs to be? Does it need to be a string? Does it need to be an object? And then you have to document that. And when they would put that in their inline code, they'd have to say, well, in this circumstance, you should pass in these options. And these options, of all these options, this one's required and these two were not, right? So you're having to document exactly how that works when you're consuming your API, right? Or when you're writing your API. With type systems, that becomes a lot easier because you can just declare an interface that says these two properties are optional and this one is required. Or you can even say, I can accept an object that is a string or just an options object. And we'll go through an example of that. So they were able to refactor their documentation, their understanding of their code base, and focus it around concepts, not around technicals, which is a powerful concept. Let's talk about Slack. Slack also integrated types into their system. How many people are Slack users? Lots of them. Most hands should go up. I figured that would be the case. So Slack's decided that they wanted to refactor their desktop client to use TypeScript. And they said, when they did that, as soon as they started renaming files, they were surprised at the number of small bugs we found when they converted their code, right? Because type errors are something that can happen, but if you don't touch a piece of code very much, they may not, right? You may call to uppercase on something that might be a number, right? And you may not be able to predict that if you've got thousands and thousands of lines of JavaScript code. So as soon as they started renaming their JS files to TS, right? And in TypeScript, it really is that easy, right? That's how you can start. They started seeing squigglies, and they said, well, we need to fix these squigglies because these squigglies mean problems. And even the smallest, as we know, even the smallest JavaScript runtime error, even the one that's most minute, that has no criticality, can just stop an entire web page. I mean, we've all had that happen to us. We deploy to production, and then suddenly somebody says, well, actually, this page doesn't work anymore because it looks like jQuery is not a function, right? That kind of stuff happens. So you don't know sometimes when these small bugs might be triggered in the future and might make your application into a showstopper, right? It might be a showstopper for your application. They also found that the more lines of code a human writes, the more inevitable it becomes to misspell a property, which we've talked about. Assume the parent of a nested object to always exist, right? When you go in dot object dot child object, right? And to use a non-standard error object. So they found the more they use types, the more they introduce types to their workflow into their JavaScript code, the more they found that they've made these minor errors that we're just prone to making. Because again, JavaScript's like, this is great, man. I love it. This is great. I think you know exactly what you're doing. You just file save, and I don't know what an error is as long as the syntax is right, right? That's just what JavaScript does. Second, they underestimated how powerful the editor integration is. Now, I'm going to show you some examples of the editor integration of TypeScript, right? But they found that when they started doing that, I mean, that suddenly they were able to see that an object of a certain type, like string, if they knew an object was a string, they knew that they had all of these methods available to it. Their tooling became a lot easier to use. And they said they understood that TypeScript understood intrinsically which properties and methods are available on objects. And if that TypeScript is able to understand that, then your editor is able to understand that, right? Because the TypeScript compiler service can talk to the editor. And any editor of your choice, right? Visual Studio Code, Notepad++. Anybody who creates a plugin that can consume that TypeScript information, they can find that out. It's kind of like Roslyn, right? It just can tell you when there's problems with your code. It can also tell you when certain objects have certain properties and methods. So it's really great. It's really great tooling. And I love this line. It's my favorite line. An autocomplete system that only uses words in the current document, and we've all used those. If we've written JavaScript, that's what we've had. Feels barbaric. It feels almost like a step backward. It's like instead of writing JavaScript in Sublime Text, they're writing it on cave walls with a chisel and a hammer, right? They felt like it was a step backwards. Kind of like once you realize the power of tooling that types provide, you never want to go back. So we've got these advantages. So let's talk about them. So we've got safety, tooling, self-documenting code. Let's dive a little bit deeper. Because type systems, beyond providing safety, I'm going to show you how they provide safety by modeling objects in ways that JavaScript actually uses objects today. So let's talk about declaring variables, declaring interfaces, and really cool types, really strange types that we don't have in .NET, like intersection and union types. So variables in JavaScript, or TypeScript, or Flow, really, when you declare them, their type inference automatically kicks in and says, okay, well, you've declared a number equal to 42, so I'm going to assume that a number is supposed to always be a number unless you annotate it differently. And I'll show you an example of that in a little bit. Thus, when you mix types, TypeScript or Flow will show an error. It'll say, like, well, you've declared this to be a number, and you don't have to do that, right? Again, TypeScript will just TypeScript will just add it in automatically, and so will Flow. You declare a number and you try to set that to a string, it's going to throw an error. Now, interestingly enough, this doesn't apply to Flow, but it does apply to TypeScript. TypeScript is a superset of JavaScript, which means that all valid JavaScript is also valid TypeScript. Thus, this is actually code that will compile. This is a code that TypeScript is identified as possibly having some kind of weakness, but it will still compile because this is still technically valid JavaScript. But it's going to tell you about it. So that way, that way you can go and fix it later, right? Because again, if you're starting to refactor JavaScript to TypeScript, it's not going to happen overnight. You're going to rename one file, and then you're going to fix those bugs and move on to the next one, or rename a few at a time, right? But it will tell you this, and it will give you nice error printout, and again, the tooling makes that really easy. An interesting thing about interfaces is that interfaces do not behave like interfaces in C# or VB.NET or Java, right? So interfaces are more concerned, they're less concerned with the object that you're declaring, right? It doesn't care that if you implement an interface on a person class, right? It cares more about the shape of the object, aka the contract, right? The properties that are on that object. And this is really powerful and important because this respects what JavaScript is, right? JavaScript by its very nature was designed to be prototypal. That is to say that it really didn't have the idea that, well, one object was not equal to another object just because the properties didn't match. But it does do that. But the idea is that JavaScript says, well, if you have an object of this shape and you have an object of another shape, in the way that most JavaScript developers behave, they're kind of considered the same object, even though they're not at runtime, right? And that's really important because, again, we're not having to interface. We don't have to declare this interface and then explicitly implement it on a class. We can just put it on the shape of an object, and it just works, right? And that's JavaScript, and declaring object literals is just a normal part of our day. So this is a really important concept. So this becomes totally valid, right? As long as you have add person is expecting a person, right? As long as you have an object that fits that shape, the add person method won't complain, right? And that's really important. It's really important because these type systems are inherently designed to respect where JavaScript came from. Another thing is generics, right? So generics were introduced to both Flow and TypeScript, and plenty of other languages that boil down to JavaScript, right? So what you have here is you can constrain, just like you can when you declare a list of something. You can constrain arrays and other kinds of objects to be only objects of a certain type. So you can declare this array as an array of people. And then you can push, just using the same interface, you can push onto that array, add to that array, an object that fits that shape. Again, same thing as we showed here, it's just applied here, but now in a more generic fashion. So that way you can reuse that array. You can't push your pets. You can't push your friend's dog. You can't add your mother-in-law to an array, because we all know she's not a person. And you can't add strings to it either, because TypeScript will say, this is not valid, right? So it gives you that guarantee. It gives you that tooling. Another interesting concept is the idea of intersection types, and this exists in both TypeScript and Flow as well, is that a lot of times, how many people do jQuery I don't know if it's extend or angular.extend or object.assign, that kind of stuff, they combine two objects into one new object, or just take the properties of one and put it on the other. Okay, a good few of you. So that's a really common JavaScript pattern. And TypeScript wanted to emulate that, right? Flow wanted to emulate that because that's just a normal part of the day. So what they created was something called intersection types. So if we have two variables here, a dog and a velociraptor, we can call an extend method, right? And if you're using extend and you're using some kind of type definition file for jQuery, for Angular, for anything that has an extend method, object.assign if you're using, if it is available in most modern browsers, it knows that once you pass in these two objects, the result will be a combination of those two. Thus, our abomination object, which combines our dog and our velociraptor, will have both a breed and a has sharp teeth property, right? And your tooling understands that. TypeScript understands that. You don't have to remember that, right? It's just one less thing to remember, one less thing to reason about, because your tooling is there to help you. Speaking of tooling, you get a lot of cool tooling, again, with type systems like Flow or TypeScript. Squigglies, that seems like a really silly thing to put on the screen until you go from C#. You've coded in C# for 5 years, or VB.NET. And as soon as you try to set the value of an object to something of a different type, you get a squiggly line, right? JavaScript doesn't have that unless you have a syntax error. They're just like, great, you know what? Like I said, you know what you're doing. I don't need a squiggly line. I don't need to guess anything. In fact, I don't even know if it's wrong, and neither do you. And that's just the way it is, right? But when you add that type system, you get squigglies. It's just one of those little tiny things that just is so great once you have it. And once you have it, you don't want to have it no more. You don't want to not have it anymore. Let's talk about this function, right? This is a very little bit of code. This is in Visual Studio Code, right? Again, something that supports the TypeScript compiler system. And we've declared a my number, and at writing time, we assume that it's a string, even though maybe we don't think it, maybe we know it isn't, but we just try it anyways. And we try to call the to lowercase because we want to convert that number to lowercase for whatever that means. And then TypeScript tells you, no, this isn't valid. This is a number. Number doesn't have to lowercase. Maybe you want to type to string or something else. You want to convert it to a string first. But it doesn't have a to lowercase function. And JavaScript just doesn't tell you about any of this stuff. But TypeScript does. And once you have this, once you start having this, again, you don't want to go back. It's a small, tiny little detail, but worth bringing up because it's an important part of how the tooling behaves. IntelliSense. Now, I love this. So this is, again, an example of this is what is called a union type. And this is a type that can be either or of something. So URL or options can either be a string or AJAX options. And the TypeScript tells you, well, I know that of these two things, there is a value of method, which is kind of like, it's a common, that and a toString method. Same thing in kind of .NET, right? You have common objects that all use the same, that they all have the same codes available to them, all the same methods. And this is the same way. It says, well, I don't know if I'm a string or an AJAX options. So what happens is I can only tell you that you have one of these two things, okay? So that's good. That's TypeScript telling you TypeScript telling you you cannot make any assumptions about this code, but it gets better. Let's look at this. So let's say that we know that the type of URL of options is a string. Suddenly, we're able to see that we can use all of these methods here. And within that block, TypeScript and Flow are contextually aware that this is a string. You don't get that in C#. You always have to do an as, cast, and check for null, right? But in TypeScript and Flow, it's just a normal part of the day, right? The tooling is able to help you. And if on the other side, it's able to do the same thing in the else block. You can do URL or options, and you can check for your URL, or you can get the type, right? You can do those things. And your tooling is there to help you the whole way, which is awesome, right? How cool is that? How many people like that? Thumbs up or down? Okay, that's cool, right? Again, JavaScript's not going to tell you any of this stuff. And this is really powerful because it just makes it predictable. So, common question. What about type definitions, right? A jQuery is a JavaScript library. How do we know what types there are? There is a community-driven project called Definitely Typed. And what it does is it aims to create interfaces for all of these objects that you consume. So jQuery being just a great example because everybody's used it and I like jQuery a lot. You can add these type definitions simply by doing npm install, right? And then give the path to whatever npm package that you want to install, right? In this case, we want to install the jQuery types. And then when you start writing your jQuery, suddenly you get IntelliSense. The cool thing about this is in certain editors like Visual Studio Code, even if you never use TypeScript, you can install this and you can start getting IntelliSense. You can start at least getting in better IntelliSense, which is a huge thing. If you haven't added NPM as part of your build process, I highly recommend you look into it. It's really pretty painless to add, even in old legacy projects. I did it in a web forms project the other day in less than 2 hours. Okay, so it's something that is certainly doable, and I would highly recommend you check that out. Refactoring. Okay, now this is just cool. I love this GIF. Check this out. Can't do this in ReSharper with JavaScript. What? I'm renaming that pet name. I'm just renaming it to name. Oh, look at that. It changed it. Okay, let's see it again. See it again. In all its majesty. Look at that. And it can do that across files. It can do that in your whole project. That's such a simple thing, but it's awesome. It's awesome once you start using it. Oh, I could just watch this GIF all day. And I made it. another really cool part, this is a part that Reddit brought up, is that your code becomes naturally more self-documenting, right? So let's say you have that Ajax request, right? You know that you're using jQuery.ajax, and you know that it can either take a URL or an options, right? An options object. So you can declare something like this. Now that thing at the top is called a string literal type. Now, string literals are usually passed around in jQuery. I mean, stringly typed is a thing that we all know about in C# and VB.NET, and it's kind of frowned upon, right? But in JavaScript, it's just kind of a normal part of the day. And what the tooling can do is kind of capture that intent, right? The TypeScript and Flow can capture that intent and say, well, we know that the only 3 strings that should be valid here are get, post, and put, or patch, but there's a bunch of HTTP verbs, but you get the idea, right? And then you have an interface that says, well, if you're going to use these Ajax options, you want a URL and you want a type, right? And if you try to call this function without that, then it's going to throw an error, right? And then you declare your function with a union type, and okay, even without any documentation, you can kind of predict, right? You can kind of reason about this code. I would predict that if it takes a string, it's probably wanting to do a GET request, or if it takes an Ajax options with a myriad of possible options, that you wanted to at least have a URL and a type so you can execute your request. Compare that to this. This is what you would do if you were writing it in just plain JavaScript, right? It's not self-documenting. It's nothing there, right? This looks way awesome. No judgment. Seriously, anybody out here who prefers this? Do they prefer this? Is there anybody out there? Okay. How many people prefer this? Lots of hands go up, right? It becomes easier to reason about because it's self-documenting. And this is what you get, right? Squigglies all the way through until you type in something valid. Then you edit it, you delete it, and you say, well, I need a URL, but then it tells you, oh, I hover over it and it says the type is missing. So then I put in a comma, I put in a type, I give it a valid option, and away we go. And that's awesome. And if you type in get, if you fat finger get, if you put in gret, something else, right? It's going to give you, again, those errors. Now, the sucky thing is that it doesn't accept lowercase, right? Get does not equal get. But at least it gives you some, it does give you some tooling. The tooling helps you along, right? It's still giving you something to work with. That's awesome. This is another GIF that I could watch all day. And this is TypeScript. You see how quickly TypeScript is able to respond to your keystrokes, which is a huge advantage. Flow the same way. Again, this goes back to the types add meaning to your code. That's the power of type systems. Okay, so you know that you want to use a type system. Which one do you choose, right? Besides TypeScript and Flow, which are kind of the main, they're certainly the easiest to kind of get into. There's even alternate languages, right? You can use a language called ReasonML, which is an ML variant that compiles down to JavaScript. If you're really crazy, you can use Elm, right? That's a complete language replacement that really does, it's really not JavaScript, but again, compiles down to JavaScript. So we're going to focus on 2 main ones, right? We're going to focus on my favorite, which is TypeScript, and we're going to focus on Flow as well, because it's another good option, right? So let's talk about Flow first. Flow is actually not a language. It is a checker, which means that it's actually checking the types. When you have a Flow file, you put usually a comment at the top of your file that says, I want Flow to check this file, right? So it actually will go through and it will give you add in your type annotations, but it's still a plain JavaScript file. And if you tried to run it, it would actually not work. Flow, you have to actually strip those type annotations out. Usually, how many people use Babel and ES6? Just out of curiosity. A few. Okay, Flow is a really good option for you, right? Because that's just a normal, if you're using Babel, there's a plugin out there that can strip those type definitions out at build time, right? For when you're compiling your code together. That's just kind of that's just kind of what Babel's good at, and Flow and Babel work really well together. Flow is made by Facebook, so it follows a lot of Facebook's opinions about how the tooling should work, right? It also has slightly better type inference. Let me give you an example. TypeScript, this is a subtle bug that could hurt you. So what we have here is an operate function that takes in 2 numbers and an operation. If the operation equals add, then we just say, well, we add them together. And you stub out this method and you kind of forget about it because you're just trying to move on to other things. But then you call this method and you forget that you don't have a subtract method, right? And this is not uncommon, okay? I run into this too. So the problem is that this is undefined. and TypeScript gave you no warning about it, okay? This is what happens. You trawl result.toString because TypeScript still interprets this to return type number, right? And that's a problem. That's a problem with TypeScript. It still says this must be of type number because you're trying to return a number. And it doesn't give you any hints about it. So that kind of sucks. But Flow will catch this. Flow will catch this and treat it for what it actually is, which is actually it's number or undefined. It's a union type saying it's number or undefined, right? So Flow will catch that really well. So that the result being that if you tried to call toString on it in Flow, you would get a compiler error. It says, well, actually, this does not work because this is not, we can't guarantee that this is a number at runtime. You can get around this in TypeScript by adding a type annotation to the end of your function declaration. So then once you do that, TypeScript will tell you that your method is incomplete and that you need to return something at least at the end of the method, right? So that's a good thing. TypeScript, on the other hand, I hate, one of the reasons that this talk's a little weird to me is because my bias is super apparent, right? But TypeScript to me has a lot of great advantages. It has excellent community support. It has excellent tooling. If Microsoft is good at one thing for developers, it's making awesome tools, right? Look at Visual Studio Code. Look where it's come in the last couple of years. It is now the de facto editor for people who don't touch .NET and never have. Right? It's now, I hear this all the time, that Visual Studio Code is overtaking Sublime, and it's free. They make really good tools for developers. The most recent Visual Studio Code has a way to refactor now JavaScript and TypeScript and extract methods from it, which is awesome, right? So they're really good at making tools. They know that that's a really important part of the developer experience. The other cool thing about TypeScript is it has modern language features, right? If you use Flow with something like ES6, right, you get classes and you get that, but you're constrained because you're still using ES6, right? It doesn't add anything to it. It's just a type checker. Whereas TypeScript has all these great modern language features like async await. It also adds classes. And TypeScript can be developed independently from all the ECMAScript specs. So ECMA, which is the official name for JavaScript, ECMAScript. ECMA is governed by a standards body called TC39. And it takes a long time for a new proposed language feature in JavaScript to make it from stage 0, which is like just a thought stage, all the way to stage 4, which is they're going to guarantee that it's going to be in a version of JavaScript. They're just not going to tell you when it's available, right? So TypeScript can develop independently because TypeScript is a product owned not by a committee, right? It's not owned by a committee, a JavaScript committee. It's owned by Microsoft. So Microsoft can go in and add those great language features. And I love async await. How many people love nested promise hell where you're calling 14 promises in a row and it looks like a pyramid on the side, right? Nobody loves that. Oh, you love that? That guy loves that. Awesome. You know what? You don't have to use TypeScript. I will keep using TypeScript because I love async await. It's awesome. It's also a little more turnkey for .NET folks. I think that TypeScript is a little easier for .NET people to kind of understand and use and add as part of their workflow. That is not to say that it's the better option solely for that, but I found that to be true. All right, this is the part of the talk where I tell you confession, right? Okay, I tell you this is really uncomfortable for me because I don't like to lie. But the reality is that your JavaScript might not need types, okay? It might need types. It probably does under lots of scenarios, but it might not. The title of the talk was like meant you to get butts and seats, and it seemed to work, and it seems to still be working because you're still here. But there are some challenges with adding types to your system, to your workflow, right? There's challenges with adding types to your development workflow. Some of which, we've already talked about the advantages, and these are great advantages, but there's still a little few things that make life just a little more difficult, right? So first thing is that it's yet another language to learn, right? Especially if you're doing something extreme like ReasonML or Elm, or you might run into a talent shortage problem. Also, when you add members to the team, you say, well, we use Flow or we use TypeScript, and now suddenly they're responsible for learning that, right? It's just another language that you have to learn. It's also a little bit of an altered workflow. JavaScript, and I can't understand this for the life of me. One engineer at my company really pushed back on adding TypeScript to our process, and he said, "I just like the JavaScript. You can move so quickly and you just work." I was like, "Yeah, and you also have the highest defect rate among all of the people here who write JavaScript. So something's weird here, right?" But he didn't like it because it did alter his workflow. Eventually, he caved and he learned to love it, but it took a while. And you're not really taking advantage of JavaScript's best feature. It pretends like it's going to work. It makes you feel good right then and there that it's going to work. All right, I'm just kidding about that one. But again, there are disadvantages. There's just a few, but there are some, and you have to be aware of them. So does your JavaScript, and I misspelled JavaScript by not capitalizing it. Good job, me. I probably should have somebody proofread these. Does your JavaScript need types if you're doing a small project? It probably doesn't. If your boss tells you, well, I want you to make a new ASP.NET MVC page, and I want it to have 3 pages, and it needs to have these JavaScript, right? You need to animate, you need to move this red box to the other side of the screen and make it blue, right? You're going to use jQuery. Well, what are the first things you're going to do? Like, well, I'm going to go file new project, and then I'm going to go ahead and add flow and TypeScript to my build process, and I need to add NPM, and you need to do all this stuff. It's maybe not worth it for 100 lines of JavaScript, right? Does your JavaScript need types if you're adding an animation to a web forms page, right? Then you're just sticking at the top of a page in a script tag, and you're like, well, 3 lines of code, I could screw it up. This is a really good time for us to try TypeScript, guys. I'm just saying, right? Probably not the best idea, right? That's not the reason to do that. Is your JavaScript code base large? Are we talking tens of files, hundreds of lines of code? Yes. Do you need to refactor often? God, yes, you need types. If you need to refactor your JavaScript often because you have junior developers or because you just suck at writing JavaScript like I do, then if you need to refactor often, then yeah, you need types. If you're talking about a mission-critical system at your company, a business-critical system, then you need types, right? Because you want to have those guarantees. You want to add those guarantees to your project. Good ways to get started. I could go over them, but it's really not the purpose of this talk. I'm trying to sell you on types. If you want to experiment, though, the flow.org and typescriptlang.org are great resources to get started, right? And again, those are not the only languages you can use. There's plenty of others. Have you and your team sit down at lunch, start Googling, right? Just start messing around with some. You'll find ones that work for you, right? Questions, usually, I've only got a couple minutes left. So usually for questions, I let folks just kind of come to me outside. So I'm going to step outside. I'm going to be out there. So come surround me, or I'm going to be up here for a while. So if you have any questions, please feel free to come see me. Again, this conversation doesn't end just because I'm not talking to you anymore. Just because I'm going to go back to the United States on Saturday, right? Tweet me. Go to my website. Email me. A guy asked me for a code sample the other day. They said, you gave this great talk, and I really would like to see a code sample. So you know what I did? I was like, well, I don't need to work, right? So I just spent 8 hours making a code sample for a guy I'd never even met before. Why I did that, I have no idea. But the point is the conversation doesn't end today, right? Come see me, come find me, come chat with me. I'm happy to talk to you about .NET, JavaScript, and all the weirdness that goes into it. Again, my name is Spencer Schneidenbach. I am having the best time in Poland. I've been all around the world. This is by far the friendliest, nicest, most welcoming country I've ever been to. It's been amazing to be here. I'm loving this conference, and I'm loving every minute of it. Thank you for being a great audience, and thank you very much.